All right, this is a very famous formula. Now listen carefully. This formula will solve any quadratic equation, okay? You can always count on this formula working. This formula always works whenever you are trying to solve a quadratic equation. Before I state what the formula is, I want to show you where it comes from. That is to say, I want to show you how it is derived. What I have written on the screen is a general quadratic equation where a, b, and c are real numbers. A is not 0, or else this whole term gets wiped away, and then this is linear. And I want you to consider solving this equation by completing the square. Now, we just learned how to complete the square, so this should be fresh in your mind. Now, in order to complete the square, the leading coefficient has to be 1. Now, we cannot assume that a represents the number 1. So we have to make sure, we have to guarantee that the leading coefficient is 1. And the way we're going to do that is by dividing every single term by a. Once we've divided everything by a, every term by a, we get x squared plus b over a, x plus c over a is equal to 0. Now, I know there's a lot of variables, or excuse me, a lot of letters on the screen here on the board, but the only variable is x. X is the variable. B over a just represents a number. C over a represents a number. Now that the leading coefficient is 1, we need this constant term to go to the other side. And we can do that by doing subtraction, using subtraction. So we're going to subtract CA from both sides, and that'll give you negative C over A on the right. Now we're ready to complete the square. We take half of the coefficient of the first degree term. Remember, this is the first degree term, and the coefficient is B over A. So I'm taking half of B over A. Don't forget how you multiply fractions. You multiply straight across. So it's 1 times B over 2 times A. Now what we need to do to this number is square it. This gives us b squared, be careful here to square the numerator and the denominator, over 4a squared. This is the square that you're adding to both sides of your equation. All right, I've added b squared over 4a squared to both sides of my equation. Now, this over here, I know it may look complicated, but this is a perfect square trinomial. So let's write that down as the square of a binomial. Now, the variable you're solving for is x. This will be plus, because that's the sign of the middle term. And then the number that goes here needs to be the number such that when you square it, you get b squared over 4a squared. Well, that's right over here. b over 2a is the number such that when you square it, you get b squared over 4a squared. So b over 2a will go right here. b over 2a. Now, as far as this right-hand side goes, you cannot add these two fractions unless they have the same denominator. The LCD is 4a squared. So you're going to have to multiply this denominator by 4a to get 4a squared. So you're going to have to multiply this by 4a, and you're going to have to multiply the numerator by 4a as well. So that way you get negative 4ac over 4a squared plus b squared over 4a squared. Now that you have common denominators, you can now add these two fractions. And you are getting, on the right, you are getting, let me just copy down this left-hand side. You are getting negative 4ac plus b squared all over 4a squared. Now, before I take the square root of both sides, I want you to realize that, or remember that, addition is commutative. The order in which you add does not matter. So what I'm going to do is I'm going to switch the order of this addition. I'm going to write it as b squared minus 4ac over 4a squared. That was using the commutative property of addition. Okay, guys, we're ready to to use the square root property. Okay. Now the square root property on the left just gives you your radicand, x plus b over 2a. Now don't forget plus or minus symbol, right? And the quotient rule for radicals will allow me to rewrite this as instead of the square root of this quotient, it'll be a quotient of square roots. So it'll be the square root of b squared minus 4ac in the numerator, and then the square root of 4a squared in the denominator. Now, I'm going to do a couple things at once here. I am going to subtract negative b over 2a from both sides in order to isolate my variable. Don't forget where you're writing this. You're going to end up writing this or placing it right in front of the plus or minus symbol. The other thing I'm going to do as well is I'm going to evaluate this square root. The square root of 4a squared is just 2a. So then this is x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now, please notice that these two terms have the same denominator. So we can actually add the numerators, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I don't know if this looks familiar to you, if you've studied this formula before, but this is the quadratic formula. It's a very popular formula, and again, it's used to solve any quadratic equation. Now, let's not forget that quadratic equations are equations that look like this, right? So don't forget when they're asking for an a value, a is your leading coefficient. B, right here, is the coefficient of your first degree term, and then c is your constant term, okay? All right, so let's solve this equation using the quadratic formula. 3x squared minus 11x is equal to positive 4. Now, the first thing you must do every single time is make sure your equation is set equal to 0. If you do not set your equation equal to 0, you may incorrectly identify what your coefficients are. So let us subtract 4 from both sides. See, now I can see that my leading coefficient, which we call a, is 3. My b value, the coefficient of the first degree term, is negative 11. And your constant term is negative 4. Not positive 4, negative 4. Now let's plug in these three numbers into the quadratic formula, okay? So here we go. X is equal to the opposite of b plus or minus the square root of b squared, use parentheses, minus 4 times a times c. Now, please don't forget that this is all over, that's very important, 2 times a. That was me applying, basically just plugging in my a, b, and c values into this formula very, very carefully, okay? It's very important that you're careful with your signs here. So you're getting positive 11 out front, plus or minus the square root of. Negative 11 squared is 121. Plus, I always count my signs. So 1, 2, right? 1 for this term here. 1, 2 negatives will give me a positive. And then 4 times 3 is 12. 12 times 4 is 48. All of this over 6. Let's continue simplifying. So x is equal to 11 plus or minus the square root of 169 all over 6. So x is equal to 11 plus or minus 13 over 6, because 13 squared gives you 169. All right, everybody, at this point, we need to say that x is equal to 11 plus 13 over 6, or x is equal to 11 minus 13 over 6. So either x is 24 over 6, which is 4, or x is negative 2 over 6, which is negative 1/3. So these are your two solutions. Please note that they are rational solutions. This next equation says 4x squared is equal to 2x plus 1. We need to set this equal to 0. There's two ways you can do that. You could either move 4x squared to the right, but then your leading coefficient would be negative. Or, maybe better, would be to move 2x and 1 to the left so that our leading coefficient remains positive. So when I subtract 2x and 1 from both sides, I get 4x squared minus 2x minus 1 is equal to 0. All right, everybody, your a value is 4, that's the leading coefficient. Your b value is negative 2, that's the coefficient of the first degree term. And c, your constant term, is negative 1. Let's use these values as we plug them in to the quadratic formula. All right, you're solving for x. X is your variable. So x is equal to negative 2 plus or minus the square root of negative 2 squared minus 4 times 4 times negative 1. Don't forget everything over 2 times 4. Okay, that was me using the formula. Now from here on out, it's just a matter of simplifying this very carefully. So x is equal to positive 2 plus or minus the square root of 4. Notice that this term has two negatives, 1, 2, so it'll be positive, and it'll be positive 16, all over 8. So then this is 2 plus or minus the square root of 20 all over 8. Now, we're going to want to simplify this, okay? Be careful how you do that, though. The numerator is 2 plus or minus. Now, the square root of 20 simplifies as 2 root 5. Don't forget earlier studies where we simplified such radicals. And then all over 8. And then what you can do at this point is factor out the GCF from the numerator, which is 2, leaving you with 1 plus or minus 1 root 5, all over 8. So now that you factored the numerator, you can now cross cancel or divide. 2 goes into 8 4 times. So then your solutions are x is equal to 1 plus or minus root 5 all over 4. These are your final solutions, and they are irrational. Irrational because 5 is not a perfect square. All right, this will be the last problem like this, okay? It's not the end of the lesson, but it is the last problem like this. Solve using the quadratic formula. All right, we need every term on one side and then 0 on the other. So let's add 2 to both sides. All right. Notice that your leading coefficient is 1. All right, let me actually write this down. I think it'd be a good idea. Your leading coefficient is 1. The coefficient of your first degree term is negative 1. And then your constant term is positive 2. These are the numbers, right? The coefficients that you're plugging into your formula. So n is equal to, that's what you're solving for, negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 2 all over 2 times 1. Okay? So then n is equal to positive 1 plus or minus the square root of 1 minus 8 all over 2. which I'm going to continue working horizontally here, which is 1 plus or minus the square root of negative 7 all over 2. So then your solutions are n is equal to 1 plus or minus I root 7 all over 2. Because these are complex conjugates, I'll rewrite this as 1 over 2 plus or minus root 7 over 2i. This is standard form, remember, for a complex number. All right, good job, everybody. All right, check this out. For each equation, write an equivalent equation so that the quadratic formula calculations will be simpler. Let me show you what they mean. Look at this first equation, 1/2 x squared minus 3/5 x plus 7/10 is equal to 0. Now, I hope that you and I do not plug these fractions into the formula. Instead, I hope that you and I would multiply every single term by the LCD so that the fractions go away, and then the quadratic formula calculations will be a lot simpler. Now, the LCD between all these fractions is 10. So if I multiply this entire equation by 10, it'll get rid of my fractions. All right, every single term has to be multiplied by 10. Here we go. Half of 10 is 5. And then here, watch this, 5 goes into 10 twice, and 2 times 3 is 6. This 10 and this 10 cancel out, leaving you with 7. So this equation is an equivalent equation, and instead of using 1/2, negative 3/5, and 7/10 in your quadratic formula, you can use the numbers 5, negative 6, and 7 instead, which would probably be so much easier. This next equation would be quite challenging to solve using the quadratic formula, namely because these coefficients are relatively large. What you can do instead is you can make these coefficients smaller if you divide by the GCF, the greatest common factor. And in this case, that would be 25. If you divide every single term by 25, you will get an equivalent equation that reads as 3x squared minus 1x plus 2 is equal to 0. Look how much better this is, everybody. So instead of plugging in the numbers 75, negative 25, and 50 into your formula, you can plug in 3, negative 1, and 2. Now for this equation, I think the obvious move here is let's get rid of these decimals. Don't forget decimals are fractions, okay? So what we can do is we can move this decimal, well, all these decimals, if we move all of them 2 units to the right, 2 spaces to the right, all for each one of these, then these coefficients become integers only instead of these fractions. Now, what would get this decimal point to move 2 places to the right? 2 places to the right is if you multiply each term by 100. After all, 0.06 is 6/100ths, 0.09 is 9/100ths, and 0.02 is 2/100ths. So if you write it as fractions, you can see that the LCD is 100. So now I hope you are fully convinced that we need to multiply by 100, okay? When you multiply by 100, notice this 100 cancels with this 100 with that 100, and that 100 with that 100. In other words, you're just left with these integer values. So the equivalent equation would be 6n squared minus 9n minus 2 is equal to 0. So instead of plugging in these decimals and it'd be quite challenging to do the calculations, we can plug in the number 6, -9, and -2. So I hope that as you're doing this work, you're keeping your eye open for ways to rewrite the equation so that the calculations are easier. Okay, so keep your eye open for that. All right, everybody, this completes this lesson on the quadratic formula. We did see where it's derived, or how it's derived, where it comes from, and we know how to use it very carefully, right? I'll catch you in the next lesson. Good job.